In this video, we're going to go over graphing inequalities. It is very, very similar to what we just did in graphing lines. We just have a couple distinctions to make. We have the option of having either a solid or a dashed line. If our symbols are less than or greater than, you're going to make a dashed line. If your symbols involve the or equals to, so less than or equal to, or greater than or equal to, you're going to make a solid line. So that's going to be a difference from the graphing lines. And then the other difference is going to be that we are going to have to shade an entire side of the line because it's no longer just going to be a line. We have to account for the greater than or the less than aspect. So let's take a look at the first example. So here we have y is less than or equal to x plus 2. The process of graphing it is going to be the same as if it was an equal sign. So we need to identify our slope, so that's that number with the x. So my slope, if there isn't a number there, it's a 1. Slope, we need rise over run, so we have a 1 over 1, or a negative 1 over negative 1. Once we've identified that, then we need to identify our y-intercept. That comes from that point right there. So our y-int is the point 0, 2. The new addition to these, as opposed to just the graphing lines, since this is an inequality, we need to take a look at that sign and figure out, are we going to make a solid or a dashed line? This is a less than or equal to symbol. So the or equal to part tells me we're going to make a solid line. So we have all the information we need. Now we can go ahead and graph it. So plot your y-intercept. That's the point 0, 2. That's this guy right here. Use your slope, up 1 over 1. That'd be right here. Up 1 over 1 right here. Here, here, and this continues on in this manner all the way up. We can go back to our y-intercept and go in the other direction. Down 1 and negative 1. That's right here. Right here. Here, here, here. Now we have enough of our points to make a good line. We know we are making a solid line because of this symbol right here. So this told us we were going to make a solid line. Let's go ahead and draw our line. Now we have to figure out what part of the line are we going to shade. Are we going to shade the top part or the bottom part? The easiest way to determine that is to take a look at your y-intercept. You're standing right here on your y-intercept. Your equation said y is less than or equal to. So if I go up here, my y value is greater than, so I don't want that one. But if I go down here, that's where my y values are less. So that is going to be the side we are going to shade. So our solution here is we have our line, and we have to shade everything below that line. Another way we could have figured out what side to shade is a more algebraic approach. We would pick a point that is not on our line. So in this case, 0, 0 is not on the line. So I'm going to use that as my test point. So my test point, I'm going to use 0, 0. Now I'm going to plug that into my equation. For the x, I'm going to replace the x with a 0. For the y, I'm going to replace it with a 0. So instead of a y, we have a 0 is less than or equal to an x, which in our case is going to be a 0, plus 2. So we have 0 is less than or equal to 2. This is a true statement, so we would shade the side that includes that test point, which we have already done. If this would have came out to be false, we would have shaded the side that does not include our test point. Both of these ways for figuring out what side of the line to shade are equally acceptable, and I do not care which one that you use. Let's look at another example. So in our second example here, we have y is less than negative x plus 2. So our process is still the same. Let's identify our slope. Our slope is the number being multiplied by the x. So in this case, my slope is a -1. I need it to be a rise over run, so we have a -1 over 1, or we have a +1 over -1. Then I need to identify my y-intercept. That comes from that number up there underlined in blue, so our y-intercept is the 0.02. And the third piece, we have to figure out what type of line we're going to make based on that inequality here. So it is a less than sign, so that tells me we're going to make a dashed line. Now we have all the pieces of information that we need in order to be able to graph. So let's go ahead and draw our graph. Plot our y-intercept, 0, 2 is right here. We're going to go down 1 and over 1, right? That'd be right here. Down 1 and over 1's right here. Here, here, so on and so forth, and we can keep going. Then we can go back and go the other direction. If we go up 1, we go in the negative direction 1. Up 1, negative direction 1. So now we have enough to make our line, and we want to make it a dashed line. So instead of making it a solid line, we're going to dash it. So here is our line. Now we have to determine what side to shade. So our first approach, if we were to take a look at our y-intercept right here, and we want to determine what side of this line we're going to shade. Our inequality said y is less than. So what side of the line are my y values less? That'd be down here. My y values are less here. So this is the side that I would shade. I would shade everything below that dashed line. When you are shading, if you're using a pencil to do your shading, just make sure you leave some space between your line and your shading so that I can tell whether your line is a dashed line or a solid line. The other way to find what side to shade was the more algebraic approach. Pick a test point. Well, again, 0, 0 does not fall on my line, so I'm going to use that as my test point. So instead of a y, I put a 0, less than -0 plus 2. So 0 is less than 2. This is a true statement, so we did shade the correct side, the side that includes that test point. Let's take a look at another example. So here we have a y is greater than 4. So y equals a number, we know that is going to be a horizontal line. So let's just go ahead and graph that. Y equals a number is a horizontal line at that number. So y equals 4 is right here. So if it was an equal sign, my line would look like this. But what type of line is not just an equal sign, it is a greater than. So we would want to make a dashed line. So we're going to go ahead and come through here and make this a dashed line. So here is our line. Now what side are we going to shade? If I stand right here at my y-intercept, what values of y, what direction on the y-axis is going to be greater than the y that I'm standing at right now? That would be this side up here. So I would shade everything above that one. Again, we can use the test point approach. Pick a point that's not on your line. 0, 0, still not on my line, so I'm going to use my test point of 0, 0 again. So 0 for y, so 0 is greater than 4. Well, that's a false statement. That is not true. So when I shade, I do not want to shade the side that includes that point. And as you can see, the yellow shading up there does not include the point 0, 0. So we shaded correctly. Let's look at another example. Here we have y is less than or equal to a negative 5/2 x plus 3. So let's identify our slope. That's the number with our x. And let's identify our y-intercept. It's going to come from this number here. So my slope is negative 5/2, or 5/-2. My y-intercept is the point 0.03. Am I going to make a solid or a dashed line? I'm going to look at my symbol here. It has the or equals to, so we're looking at a solid line. We now have all the pieces of information we need in order to graph. So let's go ahead and draw our graph. Plot our y-intercept, 0.3 is right here. And then we need to go ahead and use our slope. So down 5 and to the right 2, which is right here. We do that again, down 5 and to the right 2, which is right here. And we can go up 5 and to the left 2, which is right here. So now we can go ahead and draw our line. Obviously graphing on paper with the rulers a little bit easier than what I'm doing here. So here is our line. Now we have to figure out what side to shade. Well, I'm standing right here on my x value, or my y-intercept, sorry. My equation was y is less than or equal to. So where on the y-axis is the y value less than where I'm standing on that yellow highlighted section? Well, that would be down here. This is where my y values get smaller. So I'm going to shade everything on this side of the line. The other way, the more algebraic way to find your test point, again, 0, 0 is clearly not on my line. I can use that as my test point. So 0 is less than or equal to negative 5/2 times 0 plus 3. 0 is less than or equal to 0 plus 3. 0 less than or equal to 3. This is true. So when we shade, we do want to include the point 0, 0, which we did. Again, either way for finding which side to shade is perfectly acceptable with me. Let's look at another example. So here we have a y is less than or equal to negative 4. Again, a y equaling a number is a horizontal line. So we have our graph over here. Our symbol was a less than or equal to, so I want a solid line. So I can go ahead and graph that. Y equals negative 4 is right here. Now we need to determine what side to shade. So again, if I'm standing right here on my y-intercept, which direction on the y-axis is going to be less than the y value I'm standing at? And that's going to be down here. We can do the test point approach as well. 0, 0 is not on the line, so 0 less than or equal to negative 4. That is false. So when I shade, I do not want to include the part that has the 0, 0, which we did not. Let's look at another example. Here we have y is greater than 6x minus 3. Again, we want to identify our three key pieces of information. Our slope is 6, so we have a 6/1 or a negative 6/-1. My y-intercept comes from that last number over here, so I have the point 0, negative 3. And the third piece of information, do we want a solid or a dashed line? That is just a greater than symbol, so that tells me we're going to make a dashed line. Now we have all the information we need to be able to make our graph. So let's go ahead and draw our graph here. Plot our y-intercept, 0, negative 3. That's this guy right here. Now use our slope, up 6 and over 1. That's this guy right here. Up 6 and over 1 right here. And do the same thing going down. That'd be right here. Now we have our line that we can draw. I'm going to go ahead and draw it solid and then go back and erase to make my dashes. So there's my dashed line. Now I just needed to figure out what part to shade. So again, standing at your -3 Y-intercept right here, my equation was y is greater than, so what part of the y-axis is greater? That's going to be up here, so we want this side of the line. All of this part would be shaded. A test point here is a little more difficult because it's a little hard to tell whether 0, 0 is on the line or not based on this graph. So let's pick one, a test point that's clearly not on the line. So this guy right here, that's 0, that is a 4, 0. Sorry, -4, 0. So my test point, I'm going to pick -4 for the x value, 0 for the y. So plug in. So 0 is greater than 6 times -4 minus 3. 0 is greater than -24 minus 3. Is 0 greater than -27? Yes, it is. That is true. So we should shade the side that includes that test point. Let's look at one last example. Here we have x is greater than 5. X equals a number, that's our vertical lines. So we know we're going to have a vertical line at x equals 5. We need to figure out, do we want a solid or a dashed line? Right here tells me we want a dashed. So when I'm drawing my line at x equals 5, I want to make it a dashed line. So x equals 5 is right here. So we have this dashed line right here, and now we need to figure out what side to shade. Well, now our equation is talking about x, not y. But so stand here at my x-intercept. Our equation said x is greater. So what side does the x values get larger? That would be this side over here. So this would be the side that we are going to shade. We can do the test point option as well. 0, 0's not on my line, so we can use that. So the x is 0 is greater than 5. This would be a false statement. So when we shade, we want to shade the side that does not include that test point, which is what we did. So again, one last time, either way that you do your test point to figure out how to shade, whether you do the y-axis or x-axis greater than or less than based on the equation, or you do the actual test point algebraically, either way is fine with me. Just make sure that you do make a determination on which side to shade.